Hi everyone, welcome to IGCSE Chemistry with Abu Qai, the Chem Dude. Today we'll be looking at electrolysis of aqueous copper 2 sulfate using copper electrodes. The ions to be considered here are the copper ion, Cu, 2 plus ions from our ionic compound, and the sulfate ion, SO4, 2 minus, also from our ionic compound, copper sulfate. Since this is an aqueous solution, we must also consider the ions that are present when water partially dissociates to form H plus and OH minus ions. So we've got 4 ions here, 2 cations, and those are the Cu2 plus and H plus ions. As you would recall, cations are ions that are attracted to the cathode. And if our cathode is negatively charged, then the ions that would be attracted to a negatively charged cathode would be our positively charged ions. So our positively charged ions are our cations. So in our electrolyte there, those ions would be our copper 2 plus ion there and our hydrogen ions, which are not shown here. So I'll just write those in there. So these are our cations, positively charged ions, and therefore they're both attracted to our cathode. The ions that are attracted to our anode, our positive electrode, are the oppositely charged ions to our electrode, and those are the OH minus ion and the sulfate ion, SO4, 2 minus ion. Okay, so those ions are, here we go, I'll write them in, SO4, 2 minus, and the OH minus ions. So both of those ions are attracted to our positively charged electrode, our anode. Now, only one of them will form the product, okay, at the cathode or anode. However, since our electrode in this electrolysis process is a copper electrode, since our electrode here is copper electrode at the anode, even though the sulfate ion and the hydroxide ion are both attracted to my anode there, neither of them will form the product at the anode. And this is specifically only for the electrolysis process using copper electrodes. You would recall that when we used carbon electrodes, our sulfate and hydroxide ions both moved to the cathode, but it was our hydroxide ions that formed the product at our cathode. In this case, once we've changed the electrodes from carbon to copper, the product will totally be different. In fact, there wouldn't be a product at the anode. At the anode, there would be no product. I will go on to explain why in a minute, but let me just say, so at the anode, you will have your sulfate ion attracted to your anode, the hydroxide ion attracted to your anode, but neither of them will form the product at your anode because we are using different electrodes. We're using copper electrodes this time. My anode is a copper anode, not a carbon anode. So because I've got a copper anode, okay, neither of these anions will form the product at my anode. Now, what is copper made up of? The metal copper, what is it made up of? It's made up of copper atoms, okay? So since this copper anode is a strip of copper metal, it is made up of copper atoms, okay? What will happen here is that the copper atoms that made up this anode, they will give up 2 electrons. Each of them will give up 2 electrons, okay? So the atom there, our Cu atoms, Let me use a different color ink. So my my copper atoms there, the millions of copper atoms that are present in this piece of metal there, they will give up 2 electrons. What happens when an atom loses electrons? It turns to an ion. When an atom loses electrons, it turns to an ion. I'll show you here. So I've got my atom there. Whenever it loses copper atom, whenever it loses 2 electrons, remember it is neutrally charged. It has no charge. Okay, the number of protons and the number of electrons in an atom is exactly the same. But when it loses 2 electrons, what happens? That charge becomes unbalanced. The charge now becomes unbalanced. Okay, and now it has got two extra positive charge. Okay, so it forms an ion. It becomes an ion. So it was an atom, part of the metal, but when it lost 2 electrons, okay, it became an ion. And that ion will enter the solution. So this copper 2 plus ion that you see there, it resulted from a copper atom, perhaps this one there, giving up 2 electrons, losing 2 electrons to form this copper ion there. Okay, what happened to the 2 electrons that are lost? Those 2 electrons travels through the circuit from the anode to the cathode. Follow the arrows from the anode to the cathode. And at the cathode, exactly the same reaction occurs as in the electrolysis process using carbon electrode, but I will go over it again. Okay, so bear with me. I will come back to talk about what happens to the electrons once they reach the cathode. But let's finish up at the anode here first. So we're saying that our copper atoms, they lose these 2 electrons to form copper ions. Okay, these copper ions will travel from our anode over to our cathode. The copper ions that are formed will travel from our anode towards our cathode. Okay, now what happens? As this anode loses atoms, it will become smaller and smaller and smaller. And if the process continues, eventually the anode will disappear because it's losing atoms. Its atoms are turning to ions. This reaction is occurring. All its atoms are undergoing this reaction. They're turning to ions. So eventually, this anode will disappear. This anode will be eaten away. Okay? Now, the ions that are formed when the atoms give up their electrons, these ions, as I said, copper ions will move to the cathode. They will move to the cathode here. So I've got my Cu2 plus ions, all of these ones, they're moving to the cathode. Now, because copper is less reactive than the hydrogen ion, copper will form the product at my cathode. Copper will form the product at my cathode. Both of them will be attracted, hydrogen and copper, but it's copper that will form the product because copper is less reactive than hydrogen. In the reactivity series, which we talked about in the previous video, copper is below hydrogen. So you've got hydrogen, then copper, then silver. Yes, you've got here, and let's start from carbon, then zinc, then iron, then lead, then hydrogen, then copper, silver, and gold. I only did part of the series. Of course, there's more, okay? But we've got the ones that are relevant to us, and they are hydrogen and copper. As you can see, hydrogen is above copper Therefore, copper, being the least reactive of the two, will form the product at the cathode. So our copper will move to the cathode. It will accept the two electrons that were given up by the copper atoms over here at the anode, okay, to form copper atoms at the surface or on the surface of our cathode. So our cathode there, the surface of our cathode, will the copper there that forms our cathode will become larger and larger and larger as layers upon layers of copper are coated onto this copper cathode. So the copper cathode would become bigger and bigger and bigger. Okay, someone might want to ask, what is the point of this? Why would the atoms move, um, become ions, only to move to the cathode to become atoms again? Okay, well, the thing is, this process is very, very important. It is the process, the electrolysis process, that is used to purify copper. When copper is extracted from its ore, when copper is extracted from its ore, it is not in its purest form. It has got lots of impurities associated with it. Now, in order to remove these impurities, we would use the impure copper as our anode, okay, and a strip of pure copper as our cathode. So what would happen? The atoms from the impure copper will give up their electrons and form ions and move to the cathode, move towards the cathode, the pure cathode, okay? And at the surface of the pure cathode, they will accept those electrons to form copper atoms. So what is actually happening there? This copper there at our anode is impure, but the copper at our cathode is 100% pure, pure copper. Okay, and that is the significance of this electrolysis process. It is um, so that we can extract or manufacture pure copper, which is required for our electronic devices, your phones, the very computer that I'm using here, all requires copper wires in these electronic devices. Okay, because copper is a good conductor of electricity. So in order to get pure copper, we need to carry out this electrolysis process. Okay, now let's look at the half equations at each electrodes. I've already written the half equation there at the anode. So this is the half equation that occurs at the anode. Copper atom loses 2 electrons. Okay, each copper atom will lose 2 electrons to form a copper ion. And this is what you can see there. My copper atoms, they lose electrons to form the copper atom. Okay, this atom there loses electron to form copper ion. The ion then moves to the cathode, where it accepts that electron again, the 2 electrons again, to form pure copper atoms on the surface of my cathode. Now at the cathode, what is the half equation at the cathode? At the cathode, the half equation is Cu2 plus, that is my copper ion there, okay? It will move to the surface of my cathode and accept 2 electrons. So plus 2 electrons goes to form Cu, so the metal atom, okay? So this again, it's pure copper, and this is the technique that is used to purify copper once extracted from its ore. So that's it. That's all there is to electrolysis of copper 2 sulfate using copper electrodes. I hope you found this interesting, and I will speak to you next time we meet. Thank you very much.